In this video, we're going to find the solution to the system of equations by elimination. This is a great strategy for this particular problem because both of the equations in the system are in standard form. So in order to solve this, we want to make it so that the coefficients of one of our variables match from equation to equation, but one is a positive and one is a negative. In this case, we're going to choose to eliminate the x. That's because the coefficients of x are 2 and 4. And the lowest common multiple of those two numbers is 4. So that's actually a pretty small number. On the other hand, if we look at the y's, 3 and 7, the smallest number that they both go into is 21. So here, the x's are the better option. So what we're going to do is we're going to multiply the first equation by something so that the number in front of the x becomes negative 4. We want it to become negative 4 because, again, we want the x's to match, but one should be positive and one should be negative. Since our second equation has a positive 4, we're aiming for negative 4. So what do I multiply 2 by to make it a negative 4? Well, that's going to be negative 2. Note that what we do to one part of the equation, we're going to do to all parts of the equation. So when we multiply by negative 2, we're really distributing negative 2 to all things. This gives us negative 4x and then minus 6y equals negative 14. Now that we've done that, we can actually add our two equations, our bottom equation and the new version of our top equation after we've distributed. When we do that, 4x and negative 4x cancel. And then we have 7y minus 6y is 1y. 19 minus 14 is 5. So we've gotten rid of or eliminated the x in our equations, and we've found what the value of y is. It's possible that you'll have an equation here that you would need to solve, but in this situation, we have y equals 5 already. The y is solved for. So now we need to figure out what is our x value. So what we're going to do is we're going to take one of our two original equations and substitute the y into it. So I'm going to just use the top one. You could use either one. But instead of saying 2x plus 3y, I'm going to say 2x plus 3 times 5 equals 7. Then I multiply the 3 and 5 together to get 15. To continue solving for x, I'm going to subtract 15 on both sides. And that gives me that 2x is equal to negative 8. When I divide by 2, I find that x equals negative 4. Now that I have a value for x and I have a value for y, I can write my final solution, making sure to put them in x, y order. It is negative 4, comma 5. Remember, you can always check this by plugging it back into both of the original equations to confirm that it works.